Welcome to another episode of Tote Bag Labs Online. Subtitle, Hacking in CMajor. Subtitle, listening to my old band's music and doing effects on it. I can't believe that we put this on the record. Are we gonna do it? There we go. So currently we're using the sample and hold algorithm that was implemented in the last video. Here is how the lit downsample sounds in comparison. And of course, this one doesn't make it mono, so maybe it's not a great, but whatever. Well, there goes my basis of comparison. I guess I should really, but here's a little bait and switch. This video is not actually about the algorithm. It is going to be about branch management and refactoring, specifically because we have now 1, 2, and technically 3 different downsampling algorithms. And actually, what just happened with the one implementation being in stereo and the one being mono was kind of an object lesson into why I want to do a refactor. I want to build at least a test plugin that's going to allow us to choose in between these 3 different downsampling algorithms, both to show y'all what the differences between those algorithms sound like, and also to help myself make decisions about what I want to put in the things that I'm building. So in order to do that, we have to do some refactoring, and I actually have done a lot of this while I was away, so hooray. But we also have to do some branch management, because when I did this sample and hold, actually when I started doing the sample and hold implementation, I kind of forgot that I did the refactor, and that it wasn't on the main branch. And of course, you might ask, what the heck am I talking about? So whatever. In case you don't know, generally when we're developing a project that has any kind of complexity, i.e., something that you would actually want to ship, or maybe something that you're demonstrating to people like I'm doing, and just something that ends up getting enough stuff going on that you need to have good organization, basically. Because there are reusable parts kind of smushed together in these different parts of the implementation. It's hard to understand how these different things relate. So I'd like to keep things orderly. And one way of doing that, right, is by branching. So we have this main branch, which is the thing that, if we had a build system attached to this, and this would be what generates the release. That's what the Valentine, my compressor, downloaded down in the show description. That's the way that GitHub repo, which you can look at as well because it's open source, is structured, right? So we've got this main branch, and this is a very simple strategy, right? And I've got these feature branches here. Got one for refactoring the resampler, which that name was a little more accurate when there was only one resampler, right? Now there's multiple. And then there's this other branch called sample and hold. So the general workflow is let's simulate it, right? Let's pretend we're on some new stuff. Actually, I think I have changes. Oh, good. I already committed my changes. So great, right? Oh, you know what? Hold up. So we moved to main, and I'm going to make my text a bit bigger. There we go. So we're on main. Let's make sure we are up to date. Cool. We create a new branch. Great. And now we are safe to continue working on whatever new feature we want to work on without fear of messing up the main branch. Then eventually, when we are ready to merge back into the main branch, we will make a pull request. This is a habit that I got through work, which it's an organization of several hundred people, so you really need to be a lot more careful about communicating with other developers, and having good systems for validating the kinds of changes that you're making. But I still do this kind of thing when I am working by myself because uh, it's a bit of it's I guess it's a bit of a security blanket. It forces me to be a little more intentional about what I'm merging in, because right, an alternate way of doing things, right, is you know I could just, if I wanted to, where did my, oh, because I'm on main, of course. But why is this on main? Okay, I've got a lot of weird stuff going on here that I should probably be a little more careful about. Uh, yeah, I could make some change. I don't know. Right, and for some reason I feel like this parameter name should change. I could just do it on main. But I would prefer not to. Before I forget, oops, because I clearly forgot to. Ah, yes. Another good example here, actually, of why working off of branches is good, because I changed the name of this file and I forgot to check in the change, right? So if I had merged this into the main branch, I would have put the main branch into a broken state, which is typically not so good. In this case, it's this feature branch that is in a broken state. It's fine. I'll just fix it. Commit. We're going to commit. We're going to amend the last commit, and actually, we're going to squash, because as you can see, there's not really any significant difference between these commits. So we're going to rebase. And squash these two commits together. I like cool. So one of the complexities, however, about branching is working in this way is, as you can see, I have these two oh yeah, I do have the great. I have these two different branches of work in flight that are both based on main. But of course, they might make changes that are conflicting with each other, which is annoying, and it is simply a fact of life. The only way that you can really avoid it is by working in very different parts of a code base. So I suppose good organization can prevent this. I'm mentioning this now because I'm a little worried that I may have done something that's going to make merging in one or the other branch difficult, because I made the changes in adding the sample and hold implementation with no idea that I had made these changes and that I hadn't merged them in yet, right? So I might base some of these changes based on a reality that is not going to exist anymore. But getting this refactor done is important to me, so I'm going to put this in first, and I feel like it's better than to deal with whatever happens here, which it might not be a lot actually, because it's just something I'm afraid of. Doesn't mean that it's actually happening. So let's review this refactor, see what I did. And let's see if we're ready to merge it in. And if you've been watching, I'm just struck by, if you've been watching the initial streams of my CMajor stuff, you will see that I've progressed from like just pushing to main, not really caring, to like talking about branching strategy and doing pull requests and stuff. And it is specifically, as I said earlier, to reiterate this point, that it is a direct response to the complexity of the project, right? There's enough stuff going on now that I'm interested in reusing different elements of the project, and of just simply making my life easier as I want to add more things to these prototypes, right? So I just want to stress that this isn't something that you necessarily have to, unless if you're just hacking around, none of this is actually necessary, but this is because things have gotten just a little bit more serious. Anyway, so this first one is move channel utils to a new file. This refers to functions split mono and merge stereo. I'll show where they are in the graph for the band limited impulse train. First, I'll briefly explain what these utility functions do before we proceed. They're close to self-explanatory. In case they're not, I will explain. Split mono takes stereo input, splits it into separate mono outputs. Merge stereo accepts separate mono inputs and merges it, outputs it as one stereo output. Less self-explanatory is why. And the why is that some processors, in at least some of the processors that I want to use, aren't written in such a way that the processor itself can do stereo processing, right? You can't say, you can't specify a frame type or something, or tell it that it's going to have whatever channels to process. Rather, so in order to do stereo processing, you have to do this. You declare a separate one for each channel, right? And yeah, so in order to accommodate the mixture of processors that can do something like this and ones that don't, we have to make the connections this way, just by literally splitting signals, and then splitting signals out to mono, putting them into the mono processors that need them. And then once you're ready to go to a processor that can accept stereo output or input, you merge it in and you're on your way. So this is a function these are functions that I'm going to be using a lot. Therefore, I feel like it made sense to put these in a new folder, in a new file. So, and this seems pretty uncontroversial. Let's take a look at the notes I wrote, or the documentation. These two processors do what they say, splitting a stereo stream into two mono streams or merging two mono streams into one stereo stream. Useful for creating connections between stereo and dual mono processors. Okay, maybe I should have just said that. So that's good. What's next? Move downsampler and blit oscillator to new file. There are a few good reasons to do this. One is reusability. All of the processors for this downsampling effect were declared and implemented in the main CMajor file itself. However, there's a very good chance that I'm going to want to use this downsampler in some other effect at some point, and there's also a good chance I want to use the oscillator that this downsampler uses at some point. So putting them out in a common DSP folder makes it much more clear that these things are available for reuse. And also, this is a language specific thing, and moving them out actually makes them reusable, because in a very direct sense, because as you can see, this is marked main. If I want to include the processors if these processors were still inside of this file and I wanted to use them as part of another graph that I wanted to be the main effect, and hence marked main, it wouldn't compile. So it's pretty much essential to do this, to be able to actually have reusable code. So let's see what we did. So the obvious thing is we just deleted it. We just moved it over to new files, new beginnings, because now we have an oscillators CMajor file and we have a downsampling CMajor file. That's cool. So we need to fix these. This actually leads me to something that I'm a bit puzzled about, that I think I might not really love about CMajor as a language right now. And it's about how we declare the source file that a CMajor patch needs to run. Right. So we declare of course we declare the main one. I don't think it has to be in any specific order. The main one meaning, right, the processor or graph that is marked main. And then you list any files that are needed to make the project run. But the thing that I don't like is that as you can see, there's no way to declare dependencies between different files in a way that the top level file or the top level project, is that really a problem? I'm trying to think about this as right. So what I would like ideally is, since we are like oscillators.CMajor is not directly used by blit downsample.CMajor. However, since I've used downsampling.CMajor, I need to know that oscillators.CMajor has to be included here. And the problem for me is that there's not really, I understand why you would have to do this, right? Because how else are we going to know about oscillators.CMajor? Like the only other solution would be like a rule that's like, I don't know, if any file depends on any other file, then it needs to have some kind of JSON object like that. That's like, here are my dependencies, right? And that sounds really onerous, right? So I'm not exactly suggesting that. But the thing is that, like, you look at downsampling.CMajor, right? You don't have to declare any kind of includes. So if I were if this were presented to me as an external user, right? If I was like didn't know much about this code base and I see this downsample function, right? I'd be like, cool, I can use this in my CMajor patch, right? And I would, not knowing anything about the code base, right, and its dependencies, I would do something like this, right? And then I would try to run the patch. Oh, that's a syntax error. What are you mad at? Split down sample. Oh, well, okay, it does not like that I did this. But let's imagine, right, that I am a person who has just checked out this CMajor playground. Imagine that you are somebody that has just discovered this repository and has seen a useful bit of code, and it looks reasonably well structured, right? Like, so you trust it enough to just try grab some stuff and seeing what works, right? So you're like, cool, okay, there's a downsampler in here, I want to use it. So without knowing anything about this file's dependencies, right, you build an effect like this, right? You're like, I'm making a downsampler. It depends on the VA filters that Ollie Larkin ported over to CMajor. It requires on the it depends on these utilities functions. Cool. And it also depends on this downsampling function. And then you try to run it, and I'm pointing as if that I try to run it, and you get this really puzzling, unhelpful error, right? You know what? I might actually bring this up because it doesn't even tell you that it's missing a file, right? So let's kind of roll back the clock, right? Try to run this again. And of course, now it builds. So I suppose my real issue here is that there is no way of, it's difficult, at least from what I can see, to understand the way that different files depend on each other, which can cause some really frustrating errors, especially if the error doesn't say, hey, you're missing a file, and just gives you a kind of stock compilation error. Anyway, rant over. It took me long enough. Let's fix some things. Downsampling.CMajor. Let's see. So that needs a space. I'm just being precious because I don't like it when I feel like GitHub is judging me. And I also saw like another, yeah, There we go. Nice. And let's grab the commit. Git add. Yep. 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 Git commit. Fix up. Cool. Let's get that up there. We will fix up and then we will squash all the fix ups once we are satisfied. Move downsampler and blit oscillator to new files. Cool. And I added some sorely needed documentation. My, okay. Yeah, whatever. I'm not, am I going to be precious about? Oh, you know what? I think that I fixed this. Do I fix this later? No, it's in downsampling.CMajor. Yeah, you know what? I'm going to be okay. Good. Oh. Yeah, see, I'm caring more about these types of things as things. Ooh, and yes, git commit fix up, and I think I still have the nice. Okay, cool. So I think that is good. Now, add documentation. A Lofi sampling effect. Currently offers a 0 order hold with input and output filtering. To do this should probably operate at a fixed internal sampling rate. This is because the aliasing created changes a lot when the ratio between host and effect sample rate divide to an irrational number. Using the host sample rate then may change the sound of the effect, which we don't really want. Okay, so first off, that is there's a typo in there. Second off, I need to confirm that suspicion. And we'll talk about this on a DSP level later, because that's kind of a different I'm thinking to myself whether I actually believe this anymore. You know, I'm going to leave it for now. No, decide whether this should. And we'll address that in a later video. Yep. Git commit. No. Fix up. Cool. And oh yeah, let's push that. Then let's look at the next one. Oh. I'm going to... This was me exploring the issue I described in that comment about aliasing changing based on sample rate. And I'm actually going to drop that change because it's not a refactor. Although clearly I did want to make... So here's a thing. Here's the thing we're about to learn. I'm going to do a little bit of quick Googling. How to generate and apply patches with Git. Generate the patch. Git diff. Some changes. Dot patch. Apply the diff. Okay. So let's let's see. Refactor. This, man, I must have been real asleep at the wheel with this one. So let's get first of all, let's make sure. Oh wait, no, this is not going to. Let me think about because the issue is that I only want these changes. Oh, I know what I can do. Check this out. So first of all, get diff shows the difference between two branches, right? So what I can do, I'm on the branch, or I'm on the commit between two commits, excuse me, right? So what I can do, just do the diff against the previous commit. And yes, fantastic. The reason I'm doing this is that I think I want to at least remember these changes. So get diff, or let's go back. And then it's, what is it? Get diff some changes dot patch. Oversample and q dot patch. Cool. So now that we've saved our precious little change, I think I'm still on not sure where I am actually. Get set. Get checkout. What was the name of this branch again? Ah, yes. Okay. And now I'm just gonna drop that. We do that by rebasing and then just deleting the commit. Cool. I just want the refactor to, I don't want the refactor to change the behavior, right? So let's just not do that. Now let's get to the first commit and squash these fix ups. Auto squash. Great. That lines up all the fix ups so they get squashed. Everything is peachy. It will still build. Nice. Good. And let's see. Cool. Refactor for documentation and reusability. And there's no tests to run, so we're just going to go ahead and merge that bad boy. Cool, great. Now, let's go to our feature branch, the other one, the sample and hold one. Let's make sure that we didn't break anything, right? We're going to figure that out by fetching main, which will now have the new changes on it, right? Get rebase. We're going to rebase this branch on the new state of main. Okay, nothing's exploded yet. Let's see if our sample and hold still builds. Excellent. Do, do, do. Does it still run? Let's see. Yes. Okay. And that right there is the benefit of having tests, because you don't have to actually, grab a file and wait for it and have all this, suspense. But this doesn't have tests. It probably will never have tests because this is for prototyping. Doesn't make sense. Let's push this, or force push this. And now, as you can see, now this is up to date with main. If we diff against main, there we go. It's just, the changes. Ooh, nasty red. All right, cool. So that's it for the project work for now. One thing I want to do is I want to write another note, right? And I'm just going to get to the case first. Wow. Consider the following. Here is, I'll tell you that they will know that here is the source declaration, or the declaration of source files for this CMajor patch. In this declaration, here, I'm trying to figure out how to even articulate what my issue is, right? But downsample.CMajor depends on all the following directly. Depends on all but one of the following files. Specifically, downsampling.CMajor depends on oscillators.CMajor. I understand the need to declare oscillators.CMajor as a dependency, but am concerned about how there isn't currently a clear way of making the actual these dependencies clear. There isn't a requirement to include oscillators.CMajor in the file that is using it. So how does a new user know that they also have to include it when using downsampling.CMajor? Maybe a better error would help. Currently, failing to include the sub dependency causes a generic compilation error instead of saying that a file is missing. And let's actually, right? So let's recreate this, remove this dependency, right? Error cannot determine the type of the value to be written to this endpoint. Let's see. Okay, so would it be what do I actually want, right? First of all, I suppose what is the most clear way of declaring sub file dependencies in CMajor? I think it's not so clear when a file is required if the file is required, especially if it is a sub dependency. File is required for the patch to run. What is the most clear way of declaring file dependencies? I think it's not so clear when a file is required for the patch to run, especially if it is a subdependency. Consider the following. This list of sources, split downsample.CMajor directly depends on all but one of the following files. Specifically, downsampling.CMajor depends on oscillators.CMajor. I understand the need to declare oscillators.CMajor as a dependency, but I'm concerned about how there isn't. I'm concerned that there isn't a clear way of making. There isn't a way of making these dependencies clear to someone who doesn't already know the code well. There isn't a requirement to include oscillators.CMajor in the file that is using it. So how does a new user know that they also have to include it when using downsampling.CMajor? Maybe a better error would help. Currently failing to include the subdependency causes a generic compilation error. Instead of saying that a file is missing, cannot determine and basically, I'm probably going to leave this in the video because one thing I want to share is how I think a big part of the work here is communicating with other people, communicating with them clearly and respectfully. And if you disagree with something or have an issue or are confused, trying to really think it through and give as much information as possible so you can get a useful response and maybe even get some kind of dialogue going. Something's going to change. Either your understanding is going to change and you're going to learn a better way to use whatever it is you're having an issue with, or maybe the code or the library or whatever will change to make it work better for or, you know, to make it, to fix the error the bug that you found or something like this. So here I'm going to share my feedback on the CMajor Discord channel in order to see if, because I don't know what the solution is here, right? So I think it'll make for an interesting conversation, and I'm sure they'll bring up something that I haven't thought of before. And either way, it's not a huge deal. At least for me, I don't see myself doing a lot of production work, right, with the language. So most of my projects, I think, will be small. So, but I don't know. Either way, I think that'll be it. Next time, we will be back in the sample and hold code, not in the CMajor patch. In the sample and hold code, we're going to do a little bit of a refactor in here, specifically because one of the CMajor developers checked out the previous video and gave a lot of great suggestions on how to write it in a more idiomatic CMajor style, in a way that is more clear and more performant, possibly as well. So I think it'll be really interesting to see, you know, what we've got here and compare it to what they feel is the best way to express that code. So I hope you're looking forward to that. Thank you, as usual, for tuning in. It's been a lot of fun. And if you have any questions, hit me up on my Twitter, or check out the Tote Bag Labs Discord channel, part of the Surge Discord. Thank you very much.